Hey, it's Poisson variant to our vtuber, math lover, gamer, and nonsense enjoyer, and today we're going to be talking about finding the three-dimensional volumes of things bounded by functions and planes. When looking at finding the area underneath a regular function, we can use something called a Riemann sum. That's where we divide the area underneath the function to a bunch of rectangles, and then add all those areas together to get a pretty good approximation that we end up just converting to an integral. Using that same logic, we can cut up the top-down area of a three-dimensional solid into a bunch of rectangles and then sum those up to get an area. But we're looking for a volume. So we want to look at the bounds caused by the z equals f of x, y in the three-dimensional plane. Then, by taking the integral underneath that, we can get the volume of the entire solid. When looking in the two-dimensional case, previously, the Riemann sum was bounded by a y equals f of x, and then two x equals numbers as points. But in a three-dimensional case, we're going to be bounded by functions on the xy plane. So in order to find what our limits of integration would be for the two-dimensional, we would have to find where the lines and the functions intersect. Once we have those, we just have to look at the z-plane to get the z equals f of xy, which will be in the form of a function. Doing this, we can use two integrals back to back, integrating with respect to one variable, followed by integration with respect to another variable, and then, thanks to our limits of integration, we will have a definite answer. And this answer will be the volume of the three-dimensional object. Anyways, I've been Poisson variant to a vtuber, math lover, gamer, and nonsense enjoyer. Thank you all for watching, and bye bye!